All right, number one on the semester review, it says which statements about the figure is not true. So we're looking for not true. And it says points J, C, D, and H are coplanar. That means that they're on the same plane. And if I look at J, C, D, and H, okay, they all appear to be on this backside of this 3D shape. So that is true. They are coplanar. B lies on segment JC. Now, because it's a segment, that means it has a starting point and a stopping point. So it starts at J and it goes to C. Okay. So that means B is not on this segment over here. Right, so that is not true. Okay, but it does say statements here, so there could be more than one answer. It says point J, B, and K are non-collinear. Collinear, you're going to need to know what that means. Collinear means that it stays on the same line. So non-collinear would be not collinear. And J's here, B's here, and K. So those are not on the same line. So that would be true. They're not collinear. Ray HF and ray HD are opposite rays. And remember, those are two rays that have the same endpoint, but they are going in opposite directions. So if one's going up, the other ray has to come down. Or same thing, if it's going left, then it's got to go the opposite direction. It's got to go right. So HF, ray HF is going this way. HD is going this way. They are not opposite rays, so this one is also not true. All right. Problem number 2 is says point A, B, and C are collinear points. Point B is between points A and C, and which of the following must be true? On this one, I'm looking at the segment addition postulate, which, if you remember, we have to look at the segment and draw it out first. It says B is between points A and C. So A is one endpoint, C is the other endpoint, and B is somewhere in between them. But the segment addition postulate says that if I take the distance from A to B plus the distance from B to C, I get the whole segment AC. Alright, and so looking at this, I want to look at my addition ones first. AB plus AC, so that's AB here, AC is here. And if I add those two, I'm supposed to get this little smaller piece, which is not true. That doesn't make sense. BC and AC. Okay, so BC is this small piece here. AC is the whole thing. I can't add them together and get the smaller piece, so I know that one is not true as well. Alright, so now that means I've got to rearrange this segment addition postulate. And let's say that I want to solve for BC. So I want BC by itself. That means I'm going to have to subtract the segment AB to both sides. That goes to 0, meaning that with BC is equal to AC minus AB. Okay, now, but because it is an equality sign, I can flip both of these two over. So I'm going to say AC minus AB is equal to BC, which does match F. Right, so that is my right answer. All right, question 3, John draws a segment PQ. So I'm going to go ahead and draw a segment and label it PQ. Then he draws line L and labels point X on the line. So I'm going to draw a line, and I'm going to call that line L, and I'm going to put an X on this line here. Okay. Next, he places the compass at point P and opens the compass so the pencil is at point Q. Using that setting, he places the compass at point X and draws an arc that intersects the line at point Y. Which of the following must be true? Alright, so I measure this length here, and so I use this as my compass. So I get that length here. If I put my compass here and I rotate it this way, is what they're saying, and I label that point Y, what has to be true? Alright, so this says that the length from PQ is equal to the length of AY. That would be true, because he's describing making a congruent segment, so I know that is true. segment PQ is congruent to segment XY. Yes, because they're both segments, and we just said that they have the same length, so if they're congruent. Now, if we look at statement 3, the distance from P to X, which would be here, going this way, is that equal to the distance from Q to Y? Okay, that one would not be true because it didn't say anything about the direction of the segments. I happen to draw them both horizontally, but I could have drawn this one. I could have taken PQ and drawn it going this way, and then drawn line L going this way. And if I labeled X here, and I did my arc, and I labeled that point Y, this distance here is not the same length as that distance there. So this one would not be true. Alright, question number 4 is asking about a diagonal as a segment that connects two opposite vertices. In the figure below, what's the length of the longer diagonal? Alright, so the diagonals is talking about going from one vertex to the opposite side like this. Then I have another diagonal going this direction. Right. The longer diagonal is going to be this one. So I'm going to use the distance formula to get this one. So my first coordinate over here on the left is going to be -3, -2. And the coordinate over here is going to be 4, 3. And I want to plug those into the distance formula. So that's going to be 4 minus -3 squared plus 3 minus a -2 squared. Now, if these answer choices were in decimals, then I would just put this in the calculator and solve it that way. But since I have these simplified radicals, I have to go ahead and work this out this way. 4 plus 3 squared, 3 plus 2 squared. Okay, so this is going to give me 7 squared. This is going to give me 5 squared, which is 49 plus 25, which ends up being the square root of 74, which ends up being F.